Now let's look at this example. That is the first example. This is under quadratic function. This is a quadratic function, so this is a combination of three functions in the same system of axes. Now what we want to do is that we are given that the graphs, that is f of x is 4 negative x squared and x squared plus 6 and 3 x squared. So three of them, these they represent that is a quadratic function. Now they say as shown, that is the graph of f cuts the axis at a, c and d, and the graph of g cuts the y-axis at b. So therefore we need to determine that is the value of a, b, c and d. Okay, now let's start by looking at the value of a. How are we going to get the value of a? Now if you come here in this graph, so if now you look at this one, so this is a, it is the y-intercept of this graph here, a. Now remember, if now a is the y-intercept, that means x here, the x is 0. So that means x is 0 in that case. So we're going to use this equation here. So that means the place of x we're going to put 0, and then we solve for y because 8 is the y-intercept. Now so yeah, that means we're going to say x, and then we're going to say when x, that means the y-intercept of f is, that is a y-intercept of f is, that is 0 is to 4. Because how are we going to get that? Because if now we say a is just the y-intercept, so that means from this equation here, so I'm going to use this equation, I'm going to write it here. So that must be y is equal to 4 minus x squared, in the place of remember x is 0, y is 4. So but this is by using an inspection, but we need to work it out, and we prove that is exactly the y value is 4. We need to work it out. Okay, so that means must be y is equal to 4 minus into 0 squared, and then y is equal to 4 minus 0 must be 0, and that is the final answer should be 4. So that means now it proves that the value there, the point there should be 0 is to 4 if we're using this equation. So that means the point a, coordinates of a must be 0 is to 4. Now we go over on b. B is on this graph over here, which is this one. Okay, and again b, it is the y-intercept, so I'm going to use that equation. So I can just let's cross a line here. In fact, let me just use a space here. So again, for y-intercept, I'll just use the same color for y-intercept, and then that is y-intercept of g is should be 0 is to 6, 0 is to 6, but we need to work it out, and we see. So the equation there of g says y is equal to x squared plus 6. So that means the place of x over here, I'm going to put 0, all right, because it is a y-intercept. So must be 0 and 6, therefore y it must be just 6. Therefore the coordinates of b is going to be 0 is to 6. And then c, what about c and d? So c and d, it's easy because point c and d, these are the x-intercept, that is x1 and x2, so exactly the same function. the one that I've highlighted orange in color. So we're going to use this equation, then we solve for x, because from there that means the y value, it is 0. So the x-intercept of f, it should be let me just say r, x-intercept of fr, let me just put s there, x-intercept of fr must be 2 is to 0 and -2 is to 0. But let's just work it out and we see. So y is equal to 4 minus x squared. So that means if now we want to solve for x, so for x-intercept, don't forget that y is equal to 0. Okay, so must be 0 and we put 0. So this is a difference of 2 squared, so we just put 2 and 2, we put x and x, and it's gonna be minus, the other one should be plus, so that means we just equate each bracket equal to 0 and each bracket equal to 0, that's as well as this one. Yeah, okay, so that means must be 2 minus x is equal to 0 or 2 plus x equal to 0, and then that means must be 2 is equal to x, or must be x is equal to -2. So that means the coordinates of C and D are, that means C must be, because C is on the left hand side where x is negative, so C is on this side, D is on the other side over there. So the value of x here is negative, on that side it is positive. So D, we're going to take the positive one. For C, we're going to take the negative one. Okay, let me just try to erase this part. All right, so for C must be -2, for C must be -2 is to 0, and for D must be 2 is to 0. These are the coordinates for A, B, C, and D. Then now we go to, let's go to number 2, that is this portion, determine the coordinates of E and F. So E and F. So E, it is the point of intersection here where the two graphs intersect, as well as F. So that is the two graphs, the graph of H and the graph of F. So they intersect at E and at F. So where the two graphs intersect, so you have to equate those two equations. So this equation must be equal to this equation, and then we solve for x. So if ever you see the point of intersection, so this is how you do this graph. So now in number B, so the equation of H, now it says must be 3x squared, and the equation of f of x must be 4 minus x squared, and then we just equate the two equations together. Therefore, going to have x squared is equal to 4 minus x squared, and then we just collect the like terms. So we take x squared to that side, so that means must be 3x squared plus x squared, and then must be equal to 4. So 3 plus 1 definitely must be 4x squared, and then 4, and then we're going to just transpose 4 to the other side, must be 4x squared minus 4 is equal to 0. And then we can see that 4 is common, so we can just take out the 4 is a common factor, so must be x squared minus 1, and then equal to 0, and then we just equate each term equal to 0. Okay, so must be 4 is equal to 0, or 4 equal to 0, or x squared minus 1 equal to 0. Therefore, so must be x squared is equal to 1. Then we square root both sides, we square plus or minus, so that means x must be plus or minus. In fact, that means x, the one x is positive and the other one must be negative. So yeah, and then we have to, so this is just 0, this one. So now from here we have to check, because if this point here is 2, so therefore f, it should be 1 because it's before, and also if this one is negative 2, therefore e here should be negative 1. So that means the x value of e, it is negative 1. The x value of f, it is positive 1. So now if we want to get the value of y for f and y for e, we can use this equation, or we can use this one. Okay, so let's just take f. So that means now we're going to say y is equal to 3x squared. So I said the positive one is for e, the negative one is for e, the positive one is for f. So if we put positive now, that means I'm looking for f. So 3 into, and then squared, and then must be just 3. That is the y value. So therefore the coordinates of f must be 1 when x is 1. So y, I've just got 3. And then now I'm gonna use the same equation. Okay, and then must be y. Now if I'm using negative, so that means I'm determining that is the coordinates of e. Alright, so that means must be 3 into negative 1, so must be y is equal to also positive 3. Okay, don't forget that if you see this portion negative side, must be negative times negative, must be positive, because when you times negative become positive. So that means also the coordinates of e must be negative 1 is to 3. Okay, so now let's just confirm that. If you can check, it is possibly because these two values share the same y value. Okay, so and then from here, yeah, we're done now for e and f. Okay, so we can move on to this one, number c, the values of x for which f of x is increasing. So what we're gonna do is that so this question here, it's very easy. Let me just show you this first. So that is number c. So in question c, if now we put a graph like this, well, let me just use different color, like this way. So it's turning there, just to be, yeah, so it's turning like this way. So you must know, guys, that always on the side it is an increasing function, and on the other side definitely it is a decreasing one. Okay, so let me just draw you the inverse of this one. If now is concave up, concave up is going to be the reverse of this one. So on this side it is a decreasing now, and then on the other side it is an increasing function. Okay, and then now let's say it turns the 0 over here. So what do you do, guys, here? When you write the values of x for which f of x is increasing or decreasing. So for increasing, what do? So you check the x value of the turning point, so it is 0 now in this case. So that means you are saying that, okay, for the side of increasing, which is this portion, okay, we're not talking about the decreasing, remember, only the side of increasing. So that means my x value is less than 0. Where did I get 0? Remember, I said 0, it is the x value of the turning points. We are looking at the x value of the turning point, guys. And then if maybe we were asked to also to write down the values of x if the that is f of x is decreasing. So we're going to say x is greater. So we're saying on the right hand side greater, on the left hand side we're saying less. So on the right hand side must be greater, guys. Okay, so it's always like that. You always use the x value of the turning point. So I hope it's clear now. So that means for decreasing, for increasing, so you just say f increases, and then for all x is less than 0. Why I'm using 0? Because 0 is the x value of the turning point. But if now the x value of the turning point, maybe let's say maybe the x value of the turning point was maybe 2, was maybe 2. So that means I'm going to say x is less than 2 and x is greater than 2. Okay, so you use the x value of the turning point. Okay, so now let's try to answer this one. So they say for which values of x for f that is an increasing, so this portion here, it is an increasing function. So what is the x value of a here? A is the turning point. So a, the x value of a here, it is x is equal to what? Is equal to 0. So that means now we are looking at this portion here, at this part, only this portion, guys. That means x here is less than 0. 0, that 0, it is the x value of the turning point. All right. And then, so to answer this question, so I was just trying to show you this, guys. So you can just erase this portion. Okay, so that means we're saying that if increases for all x is less than 0. And then we're done with this question. Now let's move on to the other one. The values of all g is a decreasing function. Where is g? Oh, up there. So for decreasing function, where g is a decreasing function, where g, this one's a decreasing, I said for decreasing function, so this portion must be a decreasing, this portion. What is the x value of b? With b, which is the turning point, the x value there, it is 0. So that 0 just come up there. So that means we're going to focus only on this side. So that means x is also less than 0, only this side. But if maybe we ask that part, we're going to say x is greater than 0. So simple as that. So to answer this question then, so what do we do? So the number should be d. So we're saying f, sorry, must be g. We're saying g decreases, okay, for all, okay, that is x is less than 0. So we move on to the next one. They say the minimum, the maximum, they determine the minimum or maximum values of f and g. How do we get the minimum or the maximum values of g? So I think this one, guys, it's easy because the maximum value of f, it is 4, and then that is now looking for the maximum and the minimum value of that is of f and g. So that is the minimum values. Sorry, the maximum value refer to the largest value on the graph. All right.